Qatium.
Okay, I'm going to talk to you about how, as a small startup, we were able to work with smaller utilities, medium-sized utilities, to get them up to the standard that is required for a digital twin. And I think a lot of these discussions, and I'm sure you've had them recently, is that there's this perception that you need to have, a high quality or gold standard of hydraulic model or digital twin before you can go out there and, say that you also have the digital twin, right? There's this look that maybe your digital twin is something that has to live in the control room. It's this big flashy thing that we will have to work on for years and years to get right, and it doesn't really have to be like that. And so the way we're looking at it is through hydraulic models, and the question that comes up a lot is like, how good does your hydraulic models actually have to be? And what we found was that we would work with smaller utilities and medium-sized utilities, that we could get them to a space where we would class what they had as a digital twin that was useful for their operational purposes. So I'm going to show you through two utilities that we work with. So one was Lakewood in California. The other one was Waterloo in Canada, Ontario. So we're going to look at how the two different ways that within our startup we allow utilities to get towards their digital twin. The first way is that some utilities do not even have hydraulic models, that they're limited to it, or maybe they have hydraulic models that are very limited in their ability to get the correct answers. So the first one, Waterloo, they actually didn't have a hydraulic model, but luckily for us, Waterloo actually had an open data platform where they shared their entire GIS platform with the public. So we said, well, why don't we just take that and develop a hydraulic model for you? And so within Qatium, we can build hydraulic models. So we said, let's just try that instead. So within Qatium, it's a web-based application that you can take GIS information, like say for Waterloo, and we have a digital assistant who uses machine learning, all those fancy buzzwords that you have at the moment, and will generate a working model within minutes. So it will take the connection points, it will figure out what demands is, and generate that model for you with very minimal effort. Now, nothing is ever perfect, and this is why we're a startup, we're trying to learn. There was a few changes that we had to make. Luckily, we can download the model, make those modifications, and then get them a working model. They also had the benefit of having about 50 sensors within the ground. We were able to link into those directly and actually see the results of their model and give them something working within a couple of days. And the benefit of this as well, we could then go back to the wholesale supplier and say, well, look what we've done. And they then came to the table and they're now willing to provide the hydraulic model that they've worked on and are interested in using it themselves. And this has allowed the operators and people who wouldn't traditionally use a model to start gaining some of the benefit there. They have that they know things are working correctly. Another city that we also worked with was Lakewood in California. Sort of similar story, sort of small, about 80,000 customers. They only had a steady state model. I'm not sure there's many people here from the US. The modeling is usually much simpler there, usually steady state, just looking at the worst case scenario. So we work with the city of Lakewood and North Carolina State University to develop a plan and a process to actually upgrade their hydraulic model. So while their hydraulic model may have only been good for master planning, we wanted to move them forward so they could actually develop a fully extended period simulation model that would work as a digital twin. So we were lucky to be able to work with NCSU and work through the steps that you would have to go to an EPS. So figure out the pump curves, their settings, and we actually were able to develop a full process to convert these simple American models into something that we would class as a digital twin. And they also were able to get on the platform and have a validated hydraulic model digital twin. This learning, we're going to actually push it back into the application, so that same digital assistant you saw before, if you are not at the correct stage of your digital twin, you'll also be able to gain from the benefit that we learned from Lakewood. Now, a little bit more about digital twins and how they operate. One of the most important things is we don't want the digital twin just to be locked down to the engineers. We want it to be extended to operators, analysts, managers. Everyone should have access to the tool. So we developed a web-based application that could be deployed to everyone in the organization without any issues. So you can see here, this is the nice pressure layer. And the other area that we worked on was the validation of the model, and I know we talked about this, starting small. It's a big piece that what we're trying to do here is that we will rank your model, give you your model deviation, your difference between your live data and your model, and we're going to make it a little bit of like gamification, where you're at a certain level, and it will start giving you hints like, okay, maybe you don't have enough data yet, but maybe you can start doing fire flow analysis, maybe transfers, and then start to hint at you, okay, well, if you improve your calibration in these locations or add more sensors, maybe you can move to the next bit. So it makes those business cases much easier for utilities to know, okay, what do I need to do to move to the next level? The other areas we're working on are operational scenarios, just trying to, the traditional hydraulic modeling tools, you can do almost unlimited amount of work, but instead we want to break them down to simple operational scenarios that anyone can run. So be it selecting a pipe, finding every single customer that is impacted, and then running the simulation. We want to do that all in one click, or the same with doing what we call demand spikes, being able to select a location, run the simulation as you change the slider. So as you drag it across, see what the impact on the network is, and also seeing it at those with all the visualizations. So we just want to end with, we believe that even though we are a small company and we're working mostly with small utilities and medium utilities, there's no reason why you can't be an island with 100 people and not have a digital twin, or a city with 1 million. Everyone should be able to have access to digital twins, and that is the goal of Qatium. And it's glad that everyone is on the same boat, and we can hopefully get people moving towards the goal of having their own digital twin.
Qatium.